Okay, so you apparently have been unable to hear me up to this point. Thank you, Michael. Hopefully you can hear me now. So, sorry about that. It looks like I forgot to uncheck the button for my audio. So, as I was saying, and unfortunately no one could hear, the software we're looking at today is called pdfcrack. Yep. Right, so the software we're looking at is called pdfcrack. It's a piece of software that's intended to brute force PDFs encryption. And at least the start here is we're going to take a crack at it with AFL. We're just going to throw it in there. It's going to generate some PDFs. Well, it's not going to generate PDFs, and once we get this started, I'll explain why. But let's get this started real quick. So first things first, we're going to download some AFL. Like I was saying, and everybody missed because you can't hear me when I don't have my mic on. What we're using right here, this is just a standard EC2 instance. I believe it's the lowest tier of the compute optimized ones that I just pulled up to go ahead and run. And so what we're going to do here, we're just going to make the latest. Of course, the EC2 instances don't come with make or GCC or GDB because why would you need those things? So in order to get stuff running, we're going to have to muck around with this a little bit. But these two instances, they're super simple to get set up once you've given Amazon a credit card for them. And they're relatively efficient, and they tend to work better than just bashing things on my machine. Plus, they're going to sit up there and run for as long as I want. So what we're doing right here, we're making AFL. I just pulled it down. We have this right here. And I want the, I believe there's a, I made it, oh, it's under build, isn't it? So what I'm doing right now is I want the, I want to run the sudo make install so that it puts everything in my directory, or in my path, so I can do things like AFL just GCC, and it would just run the regular the AFL GCC rather than having to find the binary. So I have that. I now want my pdfcrack, and I'm going to do apt-get build dep for pdfcrack. What this is going to do is this is going to install all of the pieces of software that I would need to build pdfcrack, which again, it's just a random piece of software out of the apt repo. So we sit here, we install that, and then I want to do an apt get source, or is it apt cache? Yeah. And this is going out, oh, I need to add the source repos, and those are, yes, I want apt sources.list. Oh no, these are, Oh, am I being dumb here? Yeah, I'm being dumb here. It was just telling me that I couldn't verify some stuff. So, like I said, we just pulled in this piece of software. It's really a fairly simple piece of software. And the only thing we're going to do here is we're going to, I believe it uses CC for this, right? Yeah, it uses CC for this. So we're just going to set the CC is AFL. We're going to make it. And so this is going through, we just built it with their AFL. I'm going to go make dir /o/I, and then I'm going to copy from, let's see if I can remember where this is, USR share now. So AFL comes with a little bit of a test suite. Right. Actually, I'm sorry, we're going to have to do this in 2 steps, which is a little bit unfortunate. /USR local share AFL test cases others PDF small into / Okay, so that all of that is set up. We're going to do the AFL fuzz-I-o, and then we're just going to run pdfcrack with this file as arguments. Oop. Oh, I typoed that a little bit. So, and of course, I always forget to do this part. Oh. Come on. I didn't want to be in this directory. Anyway. AFL fuzz-I. /pdfcrack @. Okay. So, this can kick off. This is going to run through here for a little bit. So let's talk a little bit real quick about what pdfcrack is. pdfcrack is, again, just a random piece of software out of the apt repo, which is intended to brute force encrypted PDFs. What we're doing right now is we supplied it with a non-encrypted PDF, and right now AFL is going through and it's trying to figure out, what paths can I find through here? And it's just generating a whole bunch of them. And if we wait for a minute, we should get to a hang. So the first of the hangs is going to be when it actually generates a encrypted PDF as far as pdfcrack is concerned. So, well, let's take a look real quick. We might as well, let's leave that running. So what pdfcrack does is it goes in and the intention is that it's going to actually find an encrypted section, because PDFs apparently can have both a user password and an owner password that do encryption of some sort. I'm not actually all that clear in how it works. But what this software does is it goes through and it brute forces it. So as soon as this gets around to generating one that will work, what's going to happen is that it's going to start trying to brute force it. And that's going to be the first that are encrypted enough to actually work. And the reason this is important is because, at least with, I guess for a little bit of background here, I cheated a little bit with doing this. I actually spent a little bit of time over the weekend. I took a look at a couple different pieces of software, and I made sure that the one that I selected was not going to be devoid of bugs by some fluke. I can confirm that this piece of software has a heap corruption bug in it, and all we have to do is find it. So what we're actually going to be fuzzing, once we can get it to it, is pdfcrack will generate a save state file. If you only fuzz part of a PDF, it will, when you're trying to crack an encrypted PDF, if you break in, it will save off its current fuzzing state or brute forcing state, and you can reload it later. And as soon as we get one here that we can actually use that with, we're going to take that and we're actually going to fuzz that instead. The reason we're fuzzing the save state is, one, because that's where the heap corruption is, and two, it does almost everything that just loading a PDF does. And it has some additional software. I'm being asked in the chat about how do I know that there's a heap buffer overflow. The answer is I looked at the source code and found one. While I was waiting for some of the fuzzing to go through, I just went through, I manually did some analysis of it, and I said, oh, wait a minute, that is totally heap corruption right there. And then eventually I generated one that would do it. Huh. This is taking longer than I would hope it would. Let's see what the internet has to tell me. Encrypted PDF. How to remove PDF encryption. How to easily encrypt a PDF. I don't want any of these things. I want to create one. Seriously? Well, I guess this might be a good thing to run through real quick. So the basic version of this is that there's some sort of a header that has a dictionary. This dictionary there's a couple different algorithms can be used, as well as different revisions, and then a hashed username or a hashed user password and hashed owner password. The short version is that those apparently make a lot of use of MD5. And going through this, a lot of the stuff that is going to come up here is problems with how exactly they're handling MD5. Oh, come on. Are there really none yet? Well, let's see if we can't... So, if you're not familiar with AFL, the way that it works is you have an input directory, which is the corpus of files you're feeding in, and an output directory, which saves off all the things that are found in whatever the testing is. So that one is the original. That's not a valid PDF. So what I'm doing here is there's a queue of files that AFL thinks, or that AFL is going to use to get to new paths in this program. We see right here in the path geometry that there are 327 pending paths. So if I go into this queue directory, I believe that I should see 328 files in there, which should have all these paths. So what I'm going to do here is I'm going to find in the output directory, queue all the files. I'm then going to exec./pdfcrack this file. We're just gonna do this until, seriously, none of these. It has yet to generate an encrypted PDF. Okay. Do I have events? No, this is not going to be on the VM, even if I do. I just want an example of one. Encrypt. No. Well, this is unfortunate. So one thing that's very important about using AFL, if you're not familiar with it, is that the corpus of files you feed it are absolutely critical. If you do not have a good corpus to feed in, AFL does almost nothing. That's not true. It's not almost nothing. Oh, I know how I can do this. But it is very difficult for it to actually get anywhere. So what I'm doing here is I am going and I'm looking at QPDF. And what QPDF is it's just another, I believe it's a PDF viewer. I don't remember how exactly I stumbled across this. But the part that's important for what we're doing here is that PDF, or QPDF, has a pretty good test suite. I want to move, oh, is this, hopefully this worked. Yeah, there we go. So if I come in here, I should be able to go into, I believe, QTest, is that where they put it? Well, here. They have all of these example PDFs. No, they have all of these tests that they've set up for their software, which exercise a whole bunch of like edge cases in their PDF viewer. So I should be able to come in here and I'm going to do the same thing I was doing over there. So pdfcrack pdfcrack find qpdf, qpdf, qtest, qpdf, dash exec. I want to echo the file name, and then where's the I can't, there we go. I think it works this way in Bash, right? I know that works in Windows. I don't remember if this works in Bash or not. Nope. Ah. Okay, well, we'll just do this the hard way. Dot slash pdf crack. Okay. Look at that. So what we just did here is we got ourselves a encrypted PDF. And if only I knew which one that was. So I believe find almost always uses the same ordering. I don't think it's a random ordering. So I should expect that the second file there says it's encrypted. So we're going to copy that over here. qpdf, qpdf, qtest, qpdf, inc. So I should expect to see that if I do this, no, long password, sure. Yeah, there we go. So what we see here is we actually get it to actually start trying to crack a PDF. So we have save state 1. We're going to make a second directory. We're going to copy that save state to and then the other thing that I want to do is there's several options here for pdfcrack, which do a number of different things. But the important part that matters here is we want to... Why have none of these hung yet? This is really surprising to me. Like, I'm really surprised that AFL has yet to generate something that looks like an encrypted PDF out of over 3 million test cases. But the part that's important here is I'm going to do a -w to supply a word list, and I'm just going to use etc password. Sure. And the reason we're doing this is because the way the save states look, if there's a word list and if there isn't a word list, is different between the two. And the heap corruption is actually in this word list. At least the one that I'm aware of. Oh, of course, they were going to do that to me. if is equal to dev/random. You random. OF is equal to dict. Count is equal to 1. BS is equal to... Sure, that should be good. So what we're doing here is we're just generating a dictionary here for it to use. Okay. Let's give it 10,000 more bytes. There we go. What I needed there was I needed to get that save state because the format of these is it's just ASCII text. But the important part here is that there is a word list that it is it believes it should look for, and this file name. So we now have 2 save states for our second run of AFL. So we have this, we've set all this up. However, this time we want different arguments to this. We want to use the -l argument, which will do a -l specifies a file to open, or a save state to open, instead of a PDF to try and crack. So, we're going to do this again. Of course you do. Of course you do. So this is the downside to this, is because this is a PDF cracker, if it is not able to find the PDF, it's going to hang forever. And AFL thinks, oh, I should look forever for this thing. So what we need to do here is we're going to go into our save states, and I'm going to manually change these to have a max password length of 3. So basically just make them bail out early, rather than echo some A's into dict. I believe this should work now. Really? Okay. Nope, we want to get rid of this one. The argument here for it is a -m3, and we want enc. Wow, you're still taking a long time. About 2. There we go. Why are you doing it this way? There we go. Ah. What is going on? Okay, well, we're just going to do this the other way then. We are just going to fuzz the one file. So, as soon as we're sure that this is set up and working, there we go. So as we can see, we already have crashes. And that's because this software is, well, it has a lot of bugs. So, most of them are non-exploitable though. So let's actually take a minute while AFL is running and let's talk about why I selected this software. So, like I searched for at the beginning, I want to do an app cache show pdfcrack. So over here, so pdfcrack was apparently written by Joe Filo. I don't know who he is. He seems like a pretty decent guy. He wrote a piece of software to try and recover passwords from a encrypted PDF document. And the important parts here are that this is a very, very old piece of software. If we go to copy link address, we go to the SourceForge page. For one, it uses the sf.net URL. But the last modified time for this was July 8th, 2008. And while age of software is not necessarily indicative of bugs, I think it's generally a safe assumption that anything written before, anything, but a lot of software written more than about 5 years ago is going to be much more vulnerable to things like AFL. And the reason for that is because, especially in the past couple of years, part of the test process for a lot of developers is just to do exactly what I'm doing here. I'm just going to throw AFL at it for, an hour or two, and anything that falls out, I'm going to fix. What that means is that it becomes very hard to try and find anything that isn't, that hasn't already been fuzzed. Whereas this piece of software is old enough that nobody ever did this. I may, in fact, be the first person to ever run a fuzzer against pdfcrack. The other thing that's important about this, and part of the reason why I selected it, is because it has no real dependencies. And while this isn't, critical, it's actually the reason why I selected it, was because I sat here and I went apt cache search PDF. And there's a ton of software here that parses PDFs. And the reason I started with PDFs is just because there's a ton of PDF bugs out there. There's been, a decade of these Adobe Acrobat bugs that people have found, all sorts of PDF viewer crashes, things like that. So there's pretty good research on how to find bugs in PDFs. And at the time when I started looking at this, I had a pretty good corpus of PDFs that I expected to crash, something that, wasn't that great. And going through this list, basically just looking through this, there's so many things But, and this is important, if the software is using, say, libpoppler, which is a popular PDF rendering library, I'm probably not going to find any bugs trying to fuzz that. Because libpoppler has already had a ton of AFL thrown at it. Well, I don't know that for sure, but I think it's a safe assumption because libpoppler is the backend for evens, which is one of the default PDF viewers on a lot of Linux installs. I believe it's the default in Ubuntu. Come on. Events, yeah. Like the whatever version of Ubuntu I have here comes with events. I think it's probably a pretty safe assumption that somebody at some point has fuzzed it quite a bit and found most of the really easy bugs. So what I'm looking for is something that a developer wrote their own PDF parser, because that's much more likely to have exploitable bugs in it than something that somebody has already fuzzed all over the place. That's not to say that libpoppler is perfect and safe. In fact, I don't know that, like, I have no confirmation behind this, but I would be absolutely shocked if there were never any more bugs found in it. There's bugs in almost every piece of software out there, and it's just a matter of time until somebody comes up with a better way to find them than just throwing stuff at it. So, that's the basic reason for picking pdfcrack. It's a PDF parser, which is a complex file format, and it's something that the developer wrote themselves, and something that the developer wrote themselves many, many years ago. And all of those mean that AFL should find plenty of crashes, hopefully exploitable crashes. And as we've been running this, the answer is yes, yes indeed, AFL has found many crashes. Well, it's found many things, and let's take a look at these real quick. One of the things that AFL doesn't have, at least as far as I'm aware, I'm not a huge AFL user. I guess this is the part where I make the somewhat embarrassing admission that I've actually never found a real bug fuzzing before, unless you count throwing literal dev-urandom at a port. Other than that, almost everything I've done is through static analysis, where I've, opened up a binary in IDA or looked at the source code and found something and then went and tried to verify this. I believe at one point I did a little bit of something with anger, but that's completely different. As far as actual fuzzing, I've never actually been all that successful with it. This is actually one of my first experiences with AFL, other than just the very simple, look, I press some buttons and I see what happens. I actually spent quite a bit of time over the weekend getting all this to work and getting things up and running in it. So, if I'm wrong about anything I say about AFL, please correct me. I would much rather have somebody correct me and tell me I'm full of shit than to have bad information about AFL get out there, because it's a tool that does a lot of things, and there's a lot of places where you can mess up doing things with it. So when I say that I'm not aware of a crash triaging tool, that doesn't mean that there isn't one. It means that I don't know what it is. So the way that I've been doing crash triaging is, I believe the best name for it is pretty gross. I'm going to write a triage script for GDB, and we're going to just run this GDB script, disassembly flavor intel, because the default AT&T syntax is completely unreadable to me. Like, if it's not in Intel, I can read it, but I can't just like scan through it and understand it. Intel I'm much more comfortable with. I also want to do set logging on. What this is going to do is this is going to tell GDB that anything you would print to standard out, anything that GDB would print to standard out, I want to also get saved to a file. This is going to make it easy for me to search through it. I'm then just going to run the program. I then want to do I want to disp/i rip. So I want to print out every instruction whenever we break in. I'm going to run the program. I'm going to then print out the register state. That's it. So this is my super simple crash triaging script. I'm going to take every one of the crashes that AFL's found. AFL thinks there are 28 unique crashes. I'm going to just run them through in GDB and try and catch all of the cases that were found. So if I go back into my pdfcrack, I'm going to do a find in the O directory. I want all of my crashes. I then want to exec, and I'm going to do gdb -x, my triage script. And then I want --args, pdfcrack -l, and then the file that I found. That's it. So what we're doing here is we're executing GDB. The -x flag says to use, let's pull this up like this. Oop. I wanted Q, go away. I want screen -r. So this -x flag says to execute a script. Oh, and I also want to get -batch in there. And what -batch will do is after it finishes executing that script, it's going to exit GDB. And then the --args says that everything after this are the program you should run. So /pdf -l tells pdfcrack to load a save state, and then the curly braces are from the find command to actually run the crashing input. So if we run this, this right here is just running them through in GDB, and it's dumping everything out for me. I should have a gdb.txt file here, which has the output of all of this. And so this is each of my inputs. Wow. Crap. That's unfortunate. I did not do this quite the way I would like to have. What I want the gdb print args. Right, I should be able to do this. pdfcrack -l, sure. Go args. Okay, yeah. So what I'm doing here is I want to show the arguments, which will tell me which input actually caused the crash. And then I'm just going to remove this GDB script, the GDB log, because I want to get rid of it. Like, I want to start over and have just the one. So we go through, we run through all of these. So this is just an awful way to do crash triaging. Normally you would hopefully do something a little bit better than this, but as far as I'm aware, this is a quick, dirty, easy way to do this. And so the very first crash that that AFL found is RIP is zeros. And we'll go through in a second and actually take a look at this one. But the short version is this is non-exploitable. And the next one is a null deref, and it's non-exploitable. And the next one is the rip is zero, null deref, rip is zero, null, or rip is zero, null deref, rip is zero, an abort, which is a little interesting. Rip is zero, or null deref, sorry. Rip is zero, null deref, another null deref. This one right here is a little bit different though. So this one is actually trying to access the E structure here, I believe is, no, the S handler is a pointer that isn't initialized. But again, it's just an null deref again. Although this one might be exploitable. I haven't looked at it very much. Basically the short version is that there's a path here that doesn't initialize S handler before trying to write to it. So it might be possible, because S handler is on the heap, it might be possible that there's a case where we can get something underneath it somehow, but I haven't looked at that at all yet. rip is 0, rip is 0, rip is 0, rip is 0. Null deref, the same one as before. Rip is 0, 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 rip is 0. Null deref, null deref. Okay, that's what all those are. That's a lot of rip is 0. So let's actually talk about that one first. So gdb --args pdfcrack -l. Oh, the problem here is that Ubuntu's smart tab completion doesn't work for --args in GDB. So if I want to use it, I need to come in here like this. Let's run it. So we got our crash here. This time, now that I've run it once, I verify that it crashes. Now I can pass it in like this, no problem. So we have this sigsegv segmentation fault. Backtrace tells us that this is that we're in main. We tried to run a crack, and we were specifically trying to run crack revision 3. Okay, we can work with that. Let's look at what that is. So pdfcrack.c. Actually, before I do this, I want to set up C tags for this. Sudo apt-get install exuberant C tags. So if you've never used it before, exuberant C tags, we're going to do C tags -r in the current directory. This creates this tags file here. And what that's going to do is that's going to let us in Vim jump around a lot more easily and actually know what we're actually looking at. It has a lot of the features that you expect from an IDE this way. Oh, pdfcrack, not cracker. I don't know how we got pdfcracker out of that. But 418, let's turn on line numbers too while we're at it. Set new. So this called md5_50. And md5_50 is going to call md variant. Md variant is a pointer. If we go back here, the place where it's actually set is actually in md50 init. What's actually happening here is that, oh, that's not what I wanted to do. I want a gx md550 variant. We skipped an initialization step. So that md5_50_ variant, there's a path that this initialization doesn't occur. So we end up calling nothing. When we call that md50 variant call in md50, this one right here, it's an uninitialized variable, but because it's in the data section, it is always going to be 0. Unfortunately, despite the fact that we got control of RIP very quickly, we can't do anything useful with it. That's unfortunate. So before we go on to the other ones, what I'm going to do here is I'm actually going to kill the AFL job. So at this point, we've gotten tons of things as inputs. I'm going to kill it, though. And the reason for that is because we didn't get the heap corruption that I teased about earlier. And the reason for that is that when that happens, it actually starts trying to crack things. And, well, there's two cases, one of which it tries to crack things and will hang forever. The other way, it will just never go anywhere. So, what do? Again, there's a couple ways that we could go about solving this. The way that I'm going to solve it is I'm going to use asan. So asan is address sanitizer. It's a Clang sanitizer. If you want to, feel free to read about it. It's really great for a lot of testing. But no, I do not mean the Autistic Self-Advocacy Network. Thanks, Google. I mean address sanitizer, which is designed to basically find all sorts of buffer overflows and things like that. Out of bounds reads, out of bounds writes, invalid pointer use, things like that. The problem is that it doesn't work all that well with AFL. And AFL has an entire document on why that is. If you care about it, and want to read, there is a notes for ASAN document which talks quite a bit about it. The short version about it real quick here is that ASAN uses a ton of memory in order to do things, and AFL doesn't like that at all. So in order to do things, like it's off by default, but we can enable it by doing AFL use ASAN is equal to 1, CC is AFL-GCC, make clean all. And so what we're doing here is we are telling AFL to use the flags for ASAN in your binary. And if we just run this, actually, before we do this, oh, that's not what I wanted at all. I want to do this with just the make clean all. So I'm rebuilding it again with just the regular instrumentation. And what I'm going to do here is I'm going to make another new directory for inputs. I'm going to use AFL cmin. So AFL cmin is the corpus minimization tool. So I'm going to have an input directory, which is the queue for our last fuzz job. And our output directory is this new directory of files. And then I want to do pdfcrack -l at. And so what this is doing is this is going through and it's saying there were 132 files that AFL had in its queue to use for future fuzzing. It went through all the paths that it knew about, that it was able to find for those. It determined that instead of having those 132 files, it could do it with just 102. And while that's not a huge speed up, I mean, it is a speed up in that there's less files to process now, which is especially important because when we enable ASAN, it's going to crawl. We go from being nice, fast, and efficient to nice and slow. So we just did this again. We're going to AFL fuzz. We're going to give it an input. This time it's I3. And let's actually make a new input directory too while we're at it. I3 002. We're going to do -pdf crack -l at. And this is not going to work. And the reason this is not going to work is because it's built by ASAN and it's asking for a ton of memory. And now that I've said all this, I actually need to rebuild this again. Because one of the things that helps a lot, apparently, is to actually build the binary as a 32-bit binary. So let's go grab all the dependencies for that. I want build deps for pdfcrack I386. Oh, I don't think I've enabled that on this. Oh, yet have I? Yeah, I need to run. So in order to enable this, I have to run this first. Sudo apt-get update. So what we did here is we enabled the i386 architecture. And now when I run this, oh, you think you should be able to just build that for, okay, I will buy that that's a thing. And then I modified the make file here so that it will pass the -m32 flag to actually build with as a 32-bit binary instead of a 64-bit binary. Why didn't you work? Okay. I was hopeful that I'd be able to get away with this. When I did this the first time, I actually had to jump through all the hoops normally. I want GCC. Can I get away with just doing multilib? Was that going to work? I don't know if this is going to work. The short version is that what's happening right now is I don't have, oh, apparently that is all I needed to do. So if I do file on /pdfcrack, I should see that it is now a 32-bit binary. And the reason this is important, and let's pull that up again. The reason this is important is because basically, I actually haven't verified this, but this is what Elkamtuf says, and considering he wrote AFL and has had so much success with it, I assume that the stuff in the documentation is probably at least relatively right as far as I'm concerned. So, I can run it on a 32-bit system, or I can run a 64-bit system if I compile the binary in 32-bit mode. I did that. So let's go back. We're going to run it again. It's going to fail again. And this time, we want to pass a -m flag. And the M flag is for memory. Yeah, it's the number of megabytes of memory for the guest to use. So we're just going to give it 800 megs of memory. Oh! So this is the unfortunate part, and I don't have a good solution to it. In that, apparently, the ID 045 file, this file, causes a crash. So, like I said, I don't have a good solution for how to fix this. In AFL, as far as I can tell, if you have a crashing input, like I did. So what I did here is I ran AFL a ton with the non-ASAN build, and when I run it with the ASAN build, it's going to absolutely crawl, which is bad if I want to get a lot of coverage fast. So as far as I know, the only way to fix this is to go through manually and remove these. I mentioned this on Twitter, that I really wish there was a better way to handle this, because especially for this use case, I don't know a good way to do this. So anyway, actually, so let me think about this for a second. So one way I can do this is that it's got a non-zero return. So let me think about this for a second. I don't think I'm good enough with bash off the top of my head to do this, but so if I do find in I3, how many is this? There are 103 files there. So I want to execute pdfcrack. So no, I don't. I want, how do I do a bash if statement here properly? So bash if. So what I'm trying to do here is if when I run this, it returns a non-zero value, I want to remove the file. So if ./pdfcrack-l file, then rm the file. I think that should work, right? Ow. What? Well, let's try. You know what? I do know how to do this well enough in find what am I doing here again? So I did that, then you know what, there's only 103 files. Let's do this manually. What did we say this was? This was the 035, is that what I said? No, it was not the 35, it was the 45. So I have now removed one of the files that I wanted to have. Wait, what? Oh, no. Jeez, sorry. I want to remove 45 because that's the one that's actually causing me problems. Okay, that's good. So 67 is giving me problems. 67. At least it's running relatively quickly. I tried this before. When I was trying this over the weekend, I had over 1,000 files that I had queued up for this. So what I ended up doing was I removed a few of them, and then I just got rid of a huge chunk of my corpus to speed things up. Why am I stressed? I'm not stressed. I'm annoyed that I can't get things to work the way that I'd like them to work. Which is unfortunate, because really it should just work. Like, I'd like to think that this is super simple and that it would just work, but ugh. I really don't like that I'm doing this manually, because this is the kind of thing that I really should be able to automate, and I'm just not familiar enough with Bash to be able to do it well. Like, my bash scripting is not as good as it could be, which means that I don't know the right way to automate this. 107. One more. Hopefully just one more. 110. We're gonna get there. Bang A. How many more of these are there? So one of the most annoying parts about this is that I don't actually know how many of these are going to have to be removed. Like, at some point this is just going to work, and I will be able to go back to demonstrating what we're actually finding here. But there we go. So we finally got through all of these, and this is going to run, and hopefully we should see it find a whole bunch of brand new crashes. Now that I think about it, probably should have saved off the one that was the heap corruption crash that I pulled up. Well, the good news is that that one I know is still around. But so while we were doing that, I should have my. So we're gonna let this run over here and let it run again. So if you notice, well, I don't remember. I'm not sure if anybody remembers, but if you want to scroll back in the rewind, I believe when we were running AFL previously, we were getting something like 5,000 or 6,000 executions per second. We've now dropped down to 700 when we use the ASAN build. And basically, that's why they don't want you to do the ASAN build by default, because it's an order of magnitude slower. And when it comes to fuzzing, the throughput you can get, the number of test cases you can get per hour or day or whatever your time period is absolutely crucial to what kind of bugs you're going to be able to find and how efficient you're going to be at finding them. So that's that. So let's take a look at some of these other ones while we wait. So we had the one that I explained earlier, which is the uninitialized pointer. Actually, let's do this real quick. I want to get all of the RIPs out of this. I'm going to sort them, and then I only want the unique ones. So this only had 4 unique RIPs. There's the uninitialized function pointer call that we already talked about. There's a call in load state that's causing a problem. There's a raise, and there's null deref in memcompare. So this is actually not all of them. Again, I cheated a little bit here, and I've already done quite a bit of testing with this. So I will type to you so it's not delayed. I already did quite a bit of testing with this. So as far as I'm aware, I was able to find, I believe, 6 unique null derefs, 5 or 6 unique null derefs, the pointer, uninitialized pointer usage, and then 2 separate asserts where the program is set up to do asserts. Let's just take a quick look at this real quick. I want 4148. Is that what I wanted? Right. So this is the other one. Let's actually just take a real quick look at this one before we go on too much farther. Which input was this? This was the pdfcrack-l o crashes ID. I want ID 004. So this is with asan, which I don't know how helpful having asan is for what we're doing right now, but I don't feel like rebuilding it again. So here's where we are. We're at this sig_v, which is a segmentation fault because I also forgot that this is now a 32-bit binary, not a 64-bit binary, so RIP is not working for me. But if we do, we're trying to move from EBX, move 0 into EBX, which is clearly not going to work if EBX is 0. Disassembly flavor Intel. So what we can do here is we can do backtrace, and we can say, oh, okay, what is this actually doing? Oh, I'm sorry. I want to do 747. Come on, go to 747. Oh, we're not in the right file, are we? pdfcrack.c, 747. So basically what's happening here is, for whatever reason, shandler is 0 in this case. The pointer for shandler was 0, and we're trying to write this null byte to it. And what this is supposed to be doing is this is supposed to be null terminating a string. And if we come up here a little bit farther, it only sets up the handler, like it will only malloc for it, if the length is greater than 0. Then we're going to go through this loop up to the length times. So clearly, if length is 0, this will always fail. Because what's going to happen here is it won't be initialized, so it'll still be 0. Or it will be whatever was there before. Then it's just going to write a null byte to it. So while it's not the easiest bug to land, it might be possible to try and land this. Although incredibly difficult. So the idea here would be the E structure. Where is this actually allocated? Load state, where are you called? Load state. You were called in, you're defined in at line 704 there. I can see you're called there. You were called in main.c 236 with E as an argument, and E is calloc here, which means no, this is going to be non-exploitable. The reason this is non-exploitable is because calloc will zero out the buffer. The calloc function allocates memory for an array of n member elements of size bytes each and returns a pointer to the allocated memory. The memory is set to 0. So that means even if we were somehow able to coerce things such that some memory was allocated and then freed prior to trying to allocate E, because they're using calloc, that pointer is still going to be 0. Without tearing into this way more, we're just never going to get that to be anything but 0. Oops. So that's unfortunate, but we have more crashes to look at. So the short version is those are all the crashes that AFL found on its own. So that's AFL running without the ASAN instrumentation. But, and this is important, we now have new crashes. What do our new crashes look like? Well, let's take a look. The first one is that uninitialized function pointer. The second one is, the first one is a null deref. The second one is the uninitialized function pointer. The third one is uninitialized function pointer. This is a null deref. So if we look here, this is in the mem copy, which I believe is probably the one that we had and threw away pretty quickly. This is one of the aborts in the fourth one. Basically, there's two different asserts that the program will do. Both of them we can make fail. So let me rephrase that. I'm aware of two of which both we can make fail. Unfortunately, AFL has yet to find the heap corruption that we were talking about prior. So if we instead go into hangs, so how we're going to do this? I want to do a find in O/Q. So I'm going to find all of the Q from the initial run. I then want to execute pdfcrack -L with the file that we found. And then I want to take all of the output and dump it into just dump. I want to echo it, and then I want to do that. Why can't I do that? I can do a comma, right? Bash lets me do a comma. There we go. Nope, that did not do what I wanted to do at all. Nope, that doesn't work at all either. Nope. We're gonna get here eventually. Well, okay. Okay. Oh, of course. Really? So we have a supposed stack buffer overflow. However, it is a read. I believe what this one is, and we can take a look at it a little bit later, is actually a... Oh, did I mess up my... Yeah, it's a write. So here is the crash as far as address sanitizer is concerned. And actually, can we trigger this real quick? What's this one doing? Yeah, let's use this. So if we use O/Q/ID 000109. What? Oh, right. I want the -L because this is a save state and not just a thing. I do wish that there was a better way to do this, because so I O/Q into... So if I come in here, I find 109. The next file is 45. And unfortunately, I don't actually know a better way to handle it than this, because find will do it in order of inode, not a sorted list. So I can't just say, oh, it was 109, so the next one is going to be 110 or whatever. I suppose I could have said, oh, it was 45 that triggered it last time, let's go with that. But in any case, here's what address sanitizer has to say about this thing. Basically, for I in... Oh, yes, that is probably a much better way to do it. So I'm not sure who has the XSS in their username on YouTube, but they've commented that I really should just use a for and subshell find. That would fix a lot of the problems that I've been having here. But I'm not one of the people who uses Bash as a programming language. So a lot of these tricks, and they're not even just tricks, they're just actually using Bash properly. But let's actually trace this back. So line 236 is going to call load state, and we're tracing back here. So we have the back trace from asan, and we're just going to walk through this and take a look at what's going on. So we called load state. We have load state here. Let's turn on the line numbers while we're at it. And load state, we apparently run through this, no problem at all. No, just a second here. Sorry. We're going to run through this. And all of this is how they load their input files. I guess, let's actually take a look at what a save state looks like. So we said this was O/Q ID 045. What does this actually look like? And actually, we can actually, if we want to, it's actually just plain text. So they have a PDF. It tells you the format version, the revision, a version. I don't know what a lot of these things are. We've got all of this. There's a file ID. And if we come over on the left side, we can actually see where this is getting parsed out. So they do, like, it's going to parse out the file ID. So it's going to parse out each of these individually. Then they're going to get the string filter, and string filter is defined up here as filter and then a number. So that's going to pull out that 8 and save it into len if len is greater than 0. So what the one nullity ref we were seeing before that we looked at is if we set this 8 right here to 0, we should see that nullity ref pop up because it will set the length to 0. So it will never call this malloc, and then it will still try to write to it down here. Okay. But yeah, we go through all this works just fine. All this works just fine. They're parsing more things out, they're parsing more things out, they're parsing more things out. And then what? We get to line 789. Line 789 is going to call PW load state. Okay, PW load state. What's this doing? It's the exact same kind of stuff. It calls fscanf, and so what they're doing here is they use fscanf. The file handle is open, and then it's using just a format specifier for these. So the first thing for PW load state that's going to parse out is PM : and then a number. And if we go back over here and look at it, basically pull out this PM1, and it's going to put it into PM. And what this does is this tells it what version of how it's generating stuff. I believe, and we can look at this here and see, it supports generative and word list and maybe something else. I don't know. But those are the two that it actually supports. And what's happening here? So if it's generative, it does some stuff that isn't actually all that interesting as far as I can tell. So if you remember back when we started, I had created one that was generative, and then I actually ended up throwing away the save state for it because it was causing hangs and it wasn't doing anything useful. That's because we can actually look at this code right here. So let's do that real quick. So this right here is this is the only difference, like this code right here is the only difference between the two of them, as far as I'm aware. Lines 197 to 217. And all they're going to do there is they're going to read out two numbers with this string mpclc. They verify that the character set is less than 256 bytes. They malloc some space for that. And they're then going to read a byte at a time out of the file, null terminate it, and set the character set to that. They then read in the line break, and they will read in a password if there is one. That's it. So it doesn't do much. None of those are particularly dangerous. I believe the only thing that could be dangerous here is this car set, but it's an unsigned integer, so we can't really get much out of it, right? So there is the case here where if car set was somehow, so if car set was 0, they would malloc 1 byte, then they would they'd bring 0 bytes out of the file and null terminate it, which is fine. And there don't seem to be any other sizes that would cause anything. While I say that, there is, I believe, a 1 byte out of bounds read. There's an off by 1 that is caused by this. And as far as I know, our crashes are never going to find that. Like, AFL isn't going to find it anytime soon. The only way to find that is if we actually specified here is a generative save state. And the reason for that is because it's going to search for this car set right here, and AFL will never be able to generate the word car set there. It's not never, but the probability of it changing word list to car set is so astronomically slow that it is almost impossible for that to ever happen. So realistically, AFL will probably never try any of this code. It's just going to try this code and the other failure case if PM gets set to something else. So, yep. But, and this is important, we still have our bug. So I mentioned, and I've teased about this several times now, that there is heap corruption in this program. What is that heap corruption, you may ask? The answer is, it's this right here. So, if there's a word list, it will read in the length of the word list. It will then malloc that many bytes, and then it will fscanf the rest of the line into the buffer it just allocated. Huh. Well then. That's totally heap corruption. So what's going to happen here, and the reason why ASAN triggered on this, is because we just wrote DICT into a 1 byte buffer. And I believe it actually, I don't know, where did it trigger? Where did it actually trigger? So it triggered on the fscanf. And if we somehow made it continue, it would then trigger again on the null terminate at the end, or I'm sorry. After it successfully reads in all those bytes, it will then null terminate this and work. So let's actually take a look at this. So if we come in here, I want to copy this. So we're going to copy O/Q ID 0045 into s.sav. So if I do pdfcrack -l s.sav, s.sav, we get our heap corruption. Look at that. We have read in some bytes. S.sav. And if we instead do many bytes, many bytes, what happens. And this time, instead of the write of size 5, we have a write of size 525 because we wrote a ton more bytes into the heap. And let's get you to give me so I want to do just a make. So what I just did here is, oh, really? Did I typo that? Oh, I need to set both of these. So what I'm doing here is I'm telling it that I want you to build pdfcrack 2 when I type make. So now, what? Fine. CP pdf crack asan pdf crack make clean make CP pdf crack pdf crack none. Move pdf or CP pdf crack asan. Oh, I'm sorry. asan pdf crack. Okay. So now everything should be back to normal, right? And I should be able to do pdf crack none with s.sav. And it's telling me that a null file is not found. So if we come in here, we say we want to replace this with 1. So now it's going to read in 1 byte properly and null terminate it. So if I echo an A into D, we should see, oh look, we have our heap corruption. And if we do a gdb -- args bang bang, I should be able to do, I'm actually gonna be able to do this. What does it read this into? So it reads this into string. Actually, you know what? B passwords.c line 223. So this is just prior to us trying to do all of this. We have string. Are you going to work? Of course you're not going to work. And you're unreadable too because you decided that we should be using AT&T syntax. So we have our fscanf, or just before. We're pushing EBX, which is the file. We're pushing 805 whatever, which is the word list it's searching for. And then EAX, I expect to be the string buffer. So if I do x20x $EAX, that looks like it could be a heap address, right? Looks like they allocated, so this looks like metadata for the heap, the dlmalloc heap, right? So we have the prev length here. We have the length of the current buffer, which is 11. The 1 bit is not the length. The 1 bit is saying that the previous buffer is in use and that there are 10 bytes in this buffer that are used. So we have 10 bytes that are in use. I'm sorry. I believe the 10 bytes are these 10 hex bytes that are in use, and that this would then be the header for the next allocation. That's all it's doing. Seems simple enough. So if we then do, I want to run until we get to here. So immediately after the fscanf. Of course, I'm not sure this is going to work now. What we can see here is we just completely destroyed that heap. And this right here was the, what's it called? Top of the heap telling you how much is left to allocate. So we just completely stomped on absolutely everything. And everything died. So, what do we do from here? So we clearly have heap corruption. And when we go to free this block, we're going to fail. We're also going to fail on the next malloc we make, if we make another malloc. And if we just continue here, we are actually dying on the free, which is unfortunate because the hope here would be that we would actually get as far as another allocation and maybe we can do something useful. Because right now, all that we have is we've messed with the amount of space that malloc thinks it has remaining in the current arena. So we walk back a little bit. So we did our PW load state. That succeeded. Apparently it sets recovery to true and returns. We return successfully. If not quiet, it would print out that it loaded state. All that is fine. We're then going to open the PDF. Okay. We open the PDF. I'm sorry, do we actually do that? No, we do not. We continue on until this one. We then close the file. We verify that there's space for it. So really, we set up a handler. Let's try this again. So let's break on if we're going to make any more allocations. So we do, in fact, make more allocations. So if we remember on one of the previous streams, the printf, under certain situations, will call malloc. What's happening here is we're mallocing for the first, what's what I'm looking for? We are mallocing for the first time, When we call printf for the first time, printf is internally setting up a buffer to set up a thing. Sorry, I'm blanking right now. Malloc is being called here to set up a buffer for printf to generate the string that it's going to print out to the screen. So we do get another malloc, which is good. Unfortunately, I don't know if that's sufficient for us to actually do anything, because we don't control the size of this malloc, and this malloc is going to be too big. So this malloc should be 64K. Right? Yeah. Oh, this is, I guess, much smaller on... Am I being dumb about this? No. It's much smaller on a 32-bit process. On a 64-bit process, if you go back a couple videos, when we talked about some of the printf techniques for exploiting a printf vulnerability, one of the ones that we used in OCTF, a 0CTF, was taking advantage of printf calling malloc under certain situations. This situation, in a 64-bit process, when it first calls it, it allocates 64K, give or take. I guess in this case, on a 32-bit process, it's only allocating 400 hex bytes. So I don't think that's much help to us, because this should work fine. Yeah. So we called malloc, no problem. And if we look at our heap again, like, oh, no. So, So it knows that so it went to allocate that. It took the space we had, and if we go 400 hex bytes in, it actually, oh, I'm sorry, this is not 400 hex bytes in. We need to keep going. So 400 hex bytes in, it took the value we put there, and then it thinks there's still that much space. So the usual trick for doing this is if we can control the size that malloc will attempt to allocate, then we can force it to loop around and say, have the next allocation be in like the GOT or something. And how to heap. Seriously, this is from Shellfish. How to heap. I've mentioned this a couple times in the stream before. It is great for heap exploitation stuff. For a number of different attacks, they have these short examples in C of how to do it. And basically what we have here is the House of Force is the situation we have right here. And if you want to take a look and read through it all, the short version, though, is that if we can control the size of the next thing we're going to allocate, or not necessarily the next thing, but a future thing, and we can make it an arbitrary size, because we control the size of the next thing, it's actually going to let us loop around and hit any pointer we want on another alloc. But at least this case, we don't have that. So we called our malloc. We have another malloc. What does this malloc look like? We want ESP plus 4. Plus 4. Well, that doesn't look too useful. So we set all that up. It looks like it printed some stuff out. This is in init enc workspace. I believe we can't control this either, can we? So I want where is this? Init pdfcrack should be in the right file. Yeah, so I want line 115. So we are in this malloc, and that is malloc of size, where size is equal to 72 or 68 plus file ID len. Okay. Where does init enc key workspace? So file ID len is an argument to init enc key workspace, right? So this is called, okay, this is looking at least somewhat promising. This is called, wait, what? It's called with E. Oh, it's called with E. Okay. So if you go back into, where are we? If we're back in here, so we've allocated E, we're now loading E out of this thing. Ooh, look at that. We actually do control this value. But it has to be less than no, we don't control this value because it has to be less than 256. Because of this right here on line 717. Otherwise we return false. And if we return false, we end up bailing out and dying. Okay, so this one we don't control. Let's keep going. So we continued, we have an average speed and a current word, whatever that means. So we need to go back into this file. Which one is it? This is pdfcrack. We want line 666. Wait, what? pdfcrack.c line 666. pdfcrack.c line 666. Now, can I not do that? I thought I could do that. pdfcrack.c line 666. Okay, apparently I was in the wrong file. So we're calling malloc of size t times 16. That's not useful. We're mallocing again. This time, that's interesting. So this is a malloc in, it's similar. So it's the same path as the printf one, somewhat, where there's they're allocating stuff for the file IO. But I don't know how this one works. What's the argument look like? $ESP plus 4. You know, that's more bytes. Not bad. But it's not something we control. So at this point, we just hit the abort. So none of these allocations do we really control, which is unfortunate. So now what? So we don't control the size. What if we... So let's think this through for a minute. We have a overflow into the top of heap size. If we change whether or not the previous pointer is in use, we might be able to trigger a crap, what's the word I'm looking for? Starts with a C. It's where you combine two things together. Not collation. Collation is where you make the papers go the right direction. Okay, it doesn't matter. It's where they make it cohesive. So if we can make it free, that next allocation, this would work. But I don't think we can we? Because the next allocation is the one being made for printf. Unless we can make it call printf earlier. So if it calls printf earlier, then what's the next allocation? Oh, no, I don't want help. I do kind of hate, so on the keyboard I'm using right now, I have a tiny escape key. I'm just using the laptop keyboard. Unfortunately, what that means is that sometimes when I try and hit the escape key, instead of hitting the escape key, I hit the F1 key and get help, which is almost never what I want. I almost never want the terminal help for GNOME terminal. That's just not going to happen. So the first malloc is for the printf that they were doing, which again, we're never going to make that deallocate, so I don't think it matters. And we go through all this. The next allocation was 158. What was it? Why do you do this to me? I want to delete or disable breakpoint 2. I want to restart this to enable breakpoint 2. Continue. So this should be the one in printf. Okay. This one is an fopen? I did not know that was a thing. So fopen will call malloc? Interesting. Huh. fopen will call malloc. We might have to look into this one. So what happened here? So, well, let's actually go take a look at this real quick. We've still got some time. fopen source. Sure, I'm sure you're good enough. Malloc. You do not think you call malloc. It's interesting. Oh, I want fopen64. fopen64. Source. I want the glibc version of this, don't I? Oh, yes, I want this version. What did I say? Malek. fopen64. It's open with a file name and modes. Seriously? Why do you hate me? Okay. Main.c. Line 278. So we open the word list file here, and that is, oh, this is probably allocating the file object, isn't it? Yeah. So what happens if this fails, right? So if this fails, and we somehow made it printf earlier, then we're going to go to out2. Where is out2? Which is going to call free enc data. Which will free a whole bunch of stuff. Okay. Does that matter? I don't think that matters. What do we say here? So if opening the file fails, we'll come over here, we'll free stuff. If input file, we will free input file. If car set, we will free car set. If user password, we will free password. And we'll exit. That's tricky. So what do we actually have here? So we have this overflow, and we can overflow as far as we want. However, we're at the top of the heap when we do that. Is there a way to make us not at the top of the heap? So there's quite a bit of code here. There's all these flags. So So let's ask a question here. How okay are we with cheating? And how much cheating are we okay with? And the reason I'm asking is because if I can cheat as much as I want, then I can specify that we're going to use input file here. So if we have two -l arguments, we can make it allocate a string of our choosing, because it will, when it calls stirdup here, it'll make an allocation of whatever size we want. Then it will, if we call it a second time with the real argument, it will free the first one, which means that we can use that to create a bucket earlier on that's freed, so that when we have our overflow later, it'll be much earlier on, and we can bash something that might actually be useful that way. Like, so yeah, if we set that up right, it would actually be before that E. So if you remember, E is this structure for, like, I don't know what E stands for, but it's the thing. Like, it's their state or whatever. But it seems like it's cheating a little bit too much, right? Like, for me to be able to say, not only do you have to use very, like, feels fake enough that I'm finding a bug in a save state, to also manipulate the command line arguments to this thing seems like a little bit over the top, I think. But let's see if there's anything else. So this is one way to do it. And if we do this, I'm almost positive that this is exploitable and relatively trivially exploitable. If we don't, it checks to see if I is greater than 0. If they're unhandled arguments, it's going to put them in there. Okay. It will try and open input file. It successfully opens input file, so it allocates that. We're in the recovery bucket. So if a word list is specified, then we would free it. Again, for a word list to be specified, we have to have a what's the word I'm looking for here? We have to manipulate command line arguments, so I don't really like that. Although, who knows, maybe we'll fall back on that if that's the only thing we have. So we go into parsing the save state. So we called fscanf, we read a whole bunch of stuff in. We verified that file ID ling is sane. We then set encrypt metadata. We malloc some number of bytes. And so the number of bytes we malloc are based on the file ID len. We're not going to free it, so I don't think I care. Is there a case that we can make it free it? Like, is there a free in here that we can make happen? So what I'm thinking here is, if in the save state we can make them malloc something and then free it again because something didn't work out quite right, I'm pretty okay with that. That we have, it's a malformed save state. I mean, that's honestly here's a save state for your PDF cracking tool that's ancient is pretty long shot for it being any real security risk anyway. I'm not seeing much else. So now we're in the password load state. So what do we say happens here? So fscanf is reading in file. What happens if this is massive, right? So if this is big enough to actually have an integer overflow for this comparison, it will freeze string and then return false. If it frees string, we've already bashed the end pointer. What can we get to have happen? We can have it. I was asked in the IRC, was I rejected by NASA? The answer is no, but I kind of wish I was. So the short version behind the name is that it's actually a name that I've thrown around for a while for like CTF stuff, because I think it's relatively humorous to say that we weren't good enough to go be rocket scientists. So instead, we're just hacking shit on the internet. Like, I think it's a fun name. So when we were standing up a group of people, what's it been, a few months ago, I threw it out as a temporary name, and it kind of stuck. So I've been using it ever since. But that's the story behind that name. Going back to actually trying to land this thing. So if we have this fail, and it bails out, it frees that. When it frees it, can we force it to coalesce? Coalesce. That's the word I was looking for earlier and couldn't come up with. Coalesce. So can we make it coalesce all the way around? Maybe. That's not what I wanted. I am not in the right window. So we call that, if this fails, we return false. If we return false, we're going to fprintf, and we're going to go to out1. Out1. Out1 will attempt to close. It will free. So the problem here is that all this is doing is it's freeing a whole bunch of stuff. So I think we can have it loop around to like a relative pointer on the heap. But with that coalition, so I think if the allocation is big enough, we can make it, we can't even read in that many bytes, can we? Right? Because if it's going to read in that many bytes, if it's going to read in enough bytes to fail that fscanf, then we're not going to, like, we're going to hit the end of the heap anyway, so that's going to fail. So never mind, that doesn't seem like it works. This is unfortunate. So it's almost 9 o'clock, and we've been looking at this for about 2 hours now. Let's take a look at the crashes real quick. So we've got a whole bunch of new crashes. At this point, the answer is, unfortunately, I don't think we're going to get anywhere useful today with this. So we're going to do find O2, I believe, right? No. Yeah, maybe it was O2. O2 crashes. ID. Yep, that looks like 24 crashes. Dash exec dot slash pdfcrack. And all of this is going to go into a dump. Oh, not a valid PDF. Oh. I keep doing that. We need to load a save state. So what do we find here? So we have the null deref, we have a null deref, we have a null deref, not a save file or save file is damaged. There's an assertion, null deref, null deref. Well, no, this is the uninitialized function pointer. Uninitialized function pointer. Stack buffer overflow. So maybe we should take a look at this one next time. So there's this stack buffer overflow, which is, I believe this is an out of bounds read by 1 byte. So that's that. So that's that one. So I'm being asked about uploading some of the crashes to GitHub. Yeah, I can throw them up there. I'll probably create another repo and post them there rather than putting them in the CTF repo. But yeah, I can create a repo for the stuff I've been working on here. But yeah, so maybe next week we'll take a look at this one a little bit closer. So there's, according to address sanitizer, there's an out of bounds read in their MD5 calculation. And when I looked at it before, it looked a little weird. Like they were doing that they had passed the wrong length and they were actually going to hash, they were hashing something, but the length of the input data was actually the length of something different, not the actual input data. And it was on the stack, so they were going to do an out of bounds read and hashed into something. But I don't think that's all that useful, assuming that that's what's actually going on. But we can look at it later. So let's keep looking here, though. So there's the uninitialized pointer. This is a null deref. Null deref. Null deref. Uninitialized pointer. Null deref. Uninitialized pointer, uninitialized pointer, null deref, null deref. This is the out of bounds read again. It's the same place again. Actually, no, this one's in RC4. Interesting. So according to this, there's a couple different ways that they are causing an out of bounds read, which is interesting. But according to address sanitizer, there is an out of bounds stack buffer read. Okay. And then we have a del deref, a null deref, or uninitialized pointer, uninitialized pointer, uninitialized pointer. So not a ton else that's useful. So I guess at this point, we're about 2 hours in, and I'm probably going to call it for the night. I think I'm going to leave this fuzzing for at least a little while longer. But yeah, so at this point, what we have is so just to recap everything that we went over for anybody who joined us late or just has a bad memory, as I apparently do. What we did here is I took a look at pdfcrack. So pdfcrack is a piece of software that apparently was last updated in July of 2008 and is designed to brute force encryption passwords on PDFs. So we got that, we built it with AFL, and we ran it in AFL for some period of time. As far as I'm aware, AFL should be able to find just that way, I believe 7 unique crashes. Previously, I ran it for 2 or 3 days straight and got 30 or 40 million test cases out of that. And at that point, I'd come up with a ton of different crashes. However, all of them were asserts, null derefs, or this uninitialized function pointer. So while we were waiting for those to work, we took a look at this uninitialized function pointer and went through that a little bit and what exactly is going on. Then we killed the AFL job we were doing. We recompiled the binary as a 32-bit ELF with the Clang ASAN flags turned on. What this does is actually gives us this output like this, where if a buffer is read or written to that is outside of what Clang thinks it should be, it's actually going to abort and throw up this error message for us. And you have to enable this separately for AFL because the way that AFL does some of its performance tuning apparently completely gets screwed when you turn on ASAN. If I remember correctly, so I believe we're running 800 megabytes as the amount of memory allocated for pdfcrack with ASAN. Previously, we were fine with 50 megabytes. So if you think about a program, like the amount of space taken up explodes immensely. Some of the other things that I've tried with it, some of the other targets I was looking at for potential stuff for this week, we were looking at like needing 2 or 3 gigabytes of space easily for even fairly small programs. The end result of all this is that AFL doesn't like using ASAN, but it can. And as we can see, it actually turns up more bugs if you use it. It just does them much, much slower. So we set up AFL with asan. We ran with the output from our earlier AFL. We used AFL cmin to take all of the queued files from the first job, distill them down to some smaller set of save state corpuses, and we fed all these back in to the asan version of it. We've had that running now for about an hour, and during that time it's come up with 2 new crashes. They're not actually crashes because the program handles it okay as far as it's concerned. However, one of them is heap corruption, and it looks like there's 2 other cases of an out-of-bounds read on the stack. So that's the short version of what we did today. I guess next week I'm probably going to try and pick this up, because the heap corruption that we had, while nothing automatically jumps out at me as a way to exploit it, the situation we're at is we can bash the top of the heap. We can make a couple of mallocs after that, but we don't control the sizes of those. And then we're going to basically free everything. And I'm reluctant to say that heap corruption like that is non-exploitable, but nothing's jumping out at me. So maybe with an extra week's worth of time to think about it, something will come up and we'll have someplace to go with it. Failing that, we can take a look at some of these out-of-bounds reads and see if maybe we can turn that into something more, because asan is going to stop us in execution as soon as it detects that there's an out-of-bounds read. So it's entirely possible that after this out-of-bounds read, we can get some other type of memory corruption out of this, that it's going to, it's reading an extra byte, which means it's going to write an extra byte, which means that it's going to cause some problem down the line. But because we're stopping as soon as there's an issue with asan, we never see any of that. And who knows, if I let this run for another 2 or 3 days, or actually just let it run until next week, maybe AFL will find a new crash that I'm not aware of. But I think at this point, that's the plan for next week, is we'll go over these, maybe try and get a little bit farther with the 3 bugs that it looks like we have that might be something useful. And we'll go from there. If anybody has suggestions for other targets, I am perfectly happy to see them and at least consider them. One of the requirements that I have is that I don't want them to be something that a real 0-day vulnerability in them is going to be particularly security relevant. Because I personally think it's in bad taste for me to look at something like, let's say, Chrome. I'm not saying that in 2 hours I could find you a Chrome bug, but if I did stumble across a Chrome bug on stream like this and we actually took a look at it, I get a little bit, irresponsible to do that publicly on stream. But if there's something else that is a good idea, so an example of some of the other things that I took brief looks at but didn't get very far with, there were a couple of PNG renderers similar to this pdfcrack, where they parse some PNG and get some sort of metadata out of them. Although none of the crashes that I got out of that seemed as promising as this heap corruption one. I also took a brief look at new backgammon. Apparently it has a relatively complex system for parsing replay files. I did not get very far with actually testing that, though. But that would be something that I think is quite amusing to try and get a 0-day bug in, is some sort of, Linux game I think would be great to have bugs in. But outside of that, I think after we get through a couple weeks of this, I think what I'm eventually going to switch to is something that looks a little bit more like a browser. And some of the things that I was thinking about and are things like, look at the Python language. So there was a post, I guess it's been about a week ago now, about somebody using a NumPy memory corruption bug to break out of a Python jail. And I think something similar to that, trying to find bugs in CPython or NumPy or SciPy or something like that, uh, trying to exploit those is going to be at least somewhat similar to exploiting browser bugs, and it's going to be very similar if we were going to fuzz them to fuzzing browsers. It's something useful to look at. Another option that I think I like a little bit more than Python is actually Octave. So Octave is a open source programming language for math stuff. So it's similar to MATLAB if you're familiar with that, but an open source version of it. And looking at the bug trackers for it, it looks like they've had plenty of bugs in it recently. So it might be fun to go find some Octave exploits and build them. But that's a little ways down the line. We'll see where we get to. And like always, if you have any questions or comments, feel free to leave a comment on the video. Send me a message on Twitter. The Twitter is at MurmusCTF. I believe that's correct. Yes, at MurmusCTF. Send me a message on IRC. I idle in Freenode all the time. On Slack. I think of where else you might be able to reach me. Basically, if you have questions or comments, feel free to reach out to me and let me know. I'd be happy to hear them and hear what your thoughts are. So, thanks everybody. I think things have been good for this week, and I'll see you guys all next Monday for a CTF stream. Oh, actually, that reminds me, before I finish up here, on terms of CTF stuff, if you're interested in the CTF community, there is some, at least for me, amusing drama going on right now between Shellfish and LCBC over the outcome of ICTF. I posted some stuff on Twitter about it, the statements from both groups and all of that. The short version of it is that the ICTF organizers, which are largely Shellfish, decided to disqualify LCBC. And they've got a long write-up about why they did that. And so it stirred up some drama between the two groups. And personally, I find CTF drama great because it makes it a little bit more, it makes it interesting to watch. Because having entertaining things to watch about CTF are pretty hard. Other than things like this, where you're actually watching me do something, it's a little difficult to have something that is actually entertaining for somebody who, if you don't understand what a buffer overflow is, it's really hard to get anything out of CTF. Or you know, a buffer overflow or cross-site scripting or crypto or something like that. If you don't understand the basics there well enough, it's really hard to get something out of it. But if there's drama between teams, that's something everybody can enjoy. So feel free to check that out. Also, ACES CTF is this weekend. And it kicks off the month of CTFs, that is April. Oh, I'm sorry. Last weekend kicked it off with Nuit to Hack and the Confidence Teaser. But this weekend is going to be ACTF and my kickoff for it because I had to miss last weekend. So I'll spend all weekend playing ACES CTF, and hopefully on Monday we'll have some fun stuff to talk about as far as ACES CTF went. And hopefully have a whole bunch of fun ponables to walk through, or RE challenges, or whatever it is that I end up spending the weekend working on. So anyway, thanks everybody for watching. Feel free to let me know if you have any questions or comments. I'd like to hear from everybody. Thanks. Bye.